All right, let's do problem number 1. So I have 3x to the 7th minus 22x to the 6th plus 44. Oh my goodness. Messy, messy, messy. One of the first things you want to do is to look and see if there's anything in common you can take out. Now 3 and 22 don't have anything in common, so it's not going to be a number, but I see an x squared in all of these. So right away I know this factors to x squared times 3x to the 5th minus 22x to the 4th plus 44x to the 3rd minus 56x to the 2nd plus 128x plus 128. Now that's still a pretty ugly thing, but we now know that two of the roots are 0. Oops. 0, multiplicity 2, because it's x times x, or x minus 0 times x minus 0. So we know it must bounce there. Or that's B-O-U-N-C-E. Spell it right. Okay? Now, what's going to happen with the rest of this? So to help me with that, I went to my graph, and this is the whole thing written out. So I took out, there's the part with the x squared taken out. And you can notice at the end here, I put the x squared. So it will look like the regular function, but I took the x squared out. So when I graph it, I get this. And there's the bounce at 0. But it looks like it crosses somewhere between 0 and minus 1, or minus 1 and 0, but not right on anything. Looks like it, this looks like a line coming down, but what is it really doing there? So I might go zoom in over there just to see if I can see what's really going on there. So if I zoom in right there, oh, I'm starting to see the bounce. And so if I widen it out, zoom in again, I can see it's bouncing there at, and that is, looks like 4. So let's see if 4 is a double 0. And since I've already pulled this out, I'm going to work with what's left. So that's 3, and I want to make sure I get a coefficient for each power of x. I got x to the 5th, 4th, 3rd, 2nd, 1st, and none. So, okay, they're all here. Remember, if they're not all there, you got to put in zeros for the ones that are missing. Minus 22x to the 4th, 44x to the 3rd, minus 56x squared, 128, and 128. And I'm thinking 4 is the 0. So that would be, you add 0, 3 plus nothing is 3, multiply, that's 12. 4 times 3 is 12. Add, that's negative 10. Multiply, that's negative 40. Add, that's 4. Multiply, 16. Add, that's negative 40. Be real careful with your signs on this. Multiply by 4, that's negative 160. Add, actually, 160 minus 128 is 32 times 4. Oh, negative 32. Watch your signs carefully. That's negative 128, 0. So it went in evenly. In fact, we think because of the bounce, it should be a double 0. So it should go into what's left. So 3 plus nothing is 3 times 4 is 12. Add, I get 2 times 4 is 8. That's 12 times 4 is 48. Add, and that would be 8 times 4 is 32, 0. Yes, it went in twice. Now, if I wasn't sure, I'd want to check again, but I'm pretty sure it's only 2. It looks like a bounce. So 4 has a multiplicity of 2 because of the bounce. Okay. So back to the original here, zoom 4. At 0 and at 4, I wonder what that one is. So let's ask the calculator by going second, calculate the 0 that's between. Now this is tricky. I got to go from left to right. Between -1 and 0, enter, and I'm looking at about -0.5. -0.5. And it says, oh, -0.66666. That's -2/3. So I'm going to try -2/3 and see if that actually is a 0. 3 plus nothing is 3 times 2. -2/3 is -2. That adds to 0. Times -2/3 is still 0. 12 plus 0 is 12. Divided by 3 is 4 times -2 is -8. And that worked. So -2/3, and it looks to me like it goes straight through there. So I think that's got a multiplicity of 1, and I don't want to mess with that anymore because it went straight through. And what do I have left? Well, this is a quadratic, and I could plug it into the quadratic formula, program quad, and my A is 3, and my B is 0, and my C is 12. And since I have it in A plus BI, giving me complex, it tells me the other two zeros are 2i and -2i. But I don't have to use a calculator to get that. This was x to the 5th. So this is x to the 4th, x to the 3rd. This is x squared plus 0x plus 12. Plus 0x plus 12, and I want to get that equal to 0. So that's nothing. So I can subtract. Since there's nothing here, I don't have to use the quadratic formula. I could just subtract 12. I could use the quadratic formula, but I don't have to. Subtract 12. If this wasn't 0, I would have to use the quadratic formula. Divide by 3. And I have x squared equals -4. So x would equal, see, the square root of a negative is I, and the square root of 4 is 2. And when I do the square root, it's plus or minus. So there's my 2i and -2i. 2i is a multiplicity 1, and it's an imaginary. And -2i is a 0. It happens once, and it's imaginary. Imaginaries always come in conjugates. Okay. So now I can completely factor, and I'm going to write it right here. So I have x squared for that, x minus 4 for this twice. I have x plus 2/3 for this. I have x minus 2i for that one. And I have x plus 2i for that one. And I have to have a number here, perhaps. See, my original had a 3. This would have x times x times x times x. This would only have a 1 in front of the x to the 7th. So I need a 3 to complete the factoring. So there's the factored form. What is my y-intercept? Well, if I put in 0 for the x's, this all comes out to be 0. What's the end behavior? Well, degree 7, one side is down when it's odd and one side's up, and it could be the other way. So we look at the leading coefficient. It's positive, so if I put a big positive number in here, this is all going to be positive. So for positives, this side is going up. So I'm going to say the end behavior, that's my axis, it's going up on this side, which means it's going down on that side. Okay? Local maximums, if any. Well, let's go back and look at this. So it has to be coming up, so that must be this. So it must come up and come down and bounce, because we know it bounces at 0. And it must go up and then come back down and go back up. So there must be a maximum up here where I can't see it between -1 and 0. Between -2/3 and 0, there must be a maximum. So let's see what that is. Second, calculate the maximum that's between -2/3. I could could have put in -1, but I'll just do that. And 0. So between those two, it should be at a max, and all I need now is to pick a number between those two, which is -0.5. And it says, no, at -0.46 is where the maximum is, but the maximum is basically 11, 10.9958. So basically we got a maximum at 11 of 11. So one of them. One is 11. What's the other one? So since it comes and bounces and goes up, it must come back down, and it bounces at 4 and goes back up. This one side goes off to infinity, so it's not going to have a maximum. But there's a maximum somewhere between 0 and 4. Second, calculate the maximum between 0 and 4. And I'll just say 2 is in between them. So let's do that. And it says at 2.6, it's a maximum of 1405. 0.0702, but that's close enough. I know that you know how to find it with that. Determine the intervals where f of x is positive. Well, this part is down below 0, so it's negative because it said f of x. The y values are negative. The y values are positive. There's 0 right there and 0 right there, so we can't include those. But between -2/3 and 0, it's positive. At 0, it's 0. And then from 0 to 4, it's positive. At 4, it's 0 again. And then after 4, looks like it goes back up again. So that would be 4 to infinity. So those are the intervals where the function is positive. Okay? That's number 1, and the rest of them are on the old video.